We can simplify 360 minus 45. We can make it 315 degrees. Now, if cos of x were to equal negative root 2 over 2, we know that when cos is negative, in which two quadrants? Quadrant 2, which would be 180 degrees minus 45 degrees plus k times 360, or quadrant 3, which would be 180 degrees plus 45 degrees plus k times 360, both of these where k is an element of integers. And again, that can be simplified into 135 and this into 215 degrees. So that is working with general solution. Both cos and sine repeat themselves at an interval of 360 degrees. Tan is slightly different. Tan of x, let's say we're working with tan of x is equal to, let's say 12. Second function, in fact let's make it complicated, negative 12. Now second function tan of negative 12 on your calculator is going to give you an answer of negative 85.23 degrees. Work with second function tan of the positive 12, which will give you an answer of positive 85.24 degrees. Let's just say 85 degrees. This is called our reference angle. Now we are looking for when tan is negative. That means that x either lies in the second quadrant, which will be 180 degrees minus 85 degrees plus k times, and I'm going to finish that off now in a second. The other quadrant where tan is negative is in the fourth quadrant, which is this, either can be 360 minus 85 degrees or just 0 minus, but let's work with 360 minus 85 plus k times. Now the sine and the cos were k times 360 because the sine and the cos graphs repeated themselves at intervals of 360 degrees. That means that at every 360 degrees they were exactly the same. They repeated itself once at 360 and at negative 360, and it carried on like that. The tan graph, however, because of its asymptotes, you'll notice that the tan graph repeats itself at every 180 degrees. That's negative 90, positive 90. So the tan graph repeats itself at intervals of 180 degrees. Again, this is where k is an element of integers. That brings us on to the general solution. If I had to say sine of theta is equal to a value, that means that theta is equal to an answer, or rather the second function of that value, which is otherwise known as our reference angle, plus k times 360 degrees, where k is an element of integers. Or theta is equal to the other possible answer. Remember that sine theta, if it's equal to a positive answer, it means that theta lies in either the first or the second quadrant, whereas if it were equal to a negative value, it means that theta is lying in the third or the fourth quadrant. There are always two quadrants available. So the other possible option in this case is that theta is equal to the other option, which is our axis plus or minus our reference angle, plus k times 360 degrees, again where k is an element of integers. The same thing works for cos. For 10, it is slightly different because the 10 graph repeats itself at 180 degree intervals and not 360 degrees, as is the case with sine and cos. Therefore, if tan theta is equals to a value, it means that theta is equal to our reference angle plus k times 180 degrees, where k is an element of integers, or theta is equals to the other reference angle plus k times 180 degrees, again where k is an element of integers. I now want you to have a go at the following basic examples. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you to do read sine of theta is equal to 0,5. Now, this means that theta is equal to 30 degrees, and that's called our reference angle. Sine of theta is 0.5. That means that theta is either equal to 30 degrees. Now, the reason it's 30 degrees is because this is positive. This is in the first quadrant, so it's 30 degrees plus k times 360, or theta is equal to 180 minus 30 degrees, which, let's just write that in as 180 minus 30 degrees, plus k times 360, which is equal to 150 degrees, plus k times 360 degrees. And these all happen when k is an element of integers. K is an element of integers. That just means it can be an integer value, 0, 1, 2, -1, -2, and so on in both directions. The next one says cos of theta is equal to -√3 over 2. Now, when cos of theta is equal to √3 over 2, we know then that theta is equal to, again, 30 degrees. This is our reference angle. But cos is negative. That means that theta is either in the second or in the third quadrant. Remember CAST. In quadrant 2 and quadrant 3, cos is negative. That means that in this example here, theta is either equal to 180 degrees minus 30 degrees, which is 150 degrees, plus k times 360, or theta is equal to 180 plus 30, which is 210 degrees, plus k times 360 degrees. Both of these happen when k is an element of integers.